Welcome to another episode of Exploring the Fourth Dimension. Today, we embark on a journey into the mysterious and mind-bending world of higher dimensions. Our focus will be on a fascinating shape known as the Tesseract. This shape, which exists in the fourth dimension, challenges our understanding of geometry and space. So buckle up as we dive deep into the realm of the Tesseract and uncover its secrets. Today we're diving into the fascinating world of the Tesseract, a shape from the realm of higher dimensions. The Tesseract, also known as a hypercube, is a four-dimensional analog of a cube. But what does that really mean? To understand the Tesseract, we first need to revisit some basic concepts of geometry and dimensions. Let's start with the familiar three-dimensional cube. A cube is a solid object with 6 square faces, 12 edges, and 8 vertices. It exists in three-dimensional space, which means it has length, width, and height. We can easily visualize a cube because we live in a three-dimensional world. We know a cube has 6 faces, 12 edges, and 8 vertices. Each face is a square, and each edge connects 2 vertices. The cube is a fundamental shape in three-dimensional geometry, and it serves as a building block for understanding higher dimensional shapes. But what if we added another dimension? What if we extended our understanding of shapes beyond the 3 dimensions we are familiar with? This is where the concept of the fourth dimension comes into play. The fourth dimension is a direction that is perpendicular to the 3 dimensions we know. It is a direction that we cannot directly perceive, but we can understand it mathematically and conceptually. Enter the Tesseract, also known as a hypercube. The Tesseract is a 4-dimensional shape that extends the properties of a cube into the 4th dimension. Just as a cube is made up of 6 square faces, a tesseract is made up of 8 cubic cells. These cells are connected in a way that is difficult to visualize, but they form a coherent structure in 4-dimensional space. It's the 4-dimensional analog of a cube. To understand this, let's think about how shapes evolve as we add dimensions. A point is a 0-dimensional object. When we extend a point in one direction, we get a line segment, which is a 1-dimensional object. Extending a line segment in a perpendicular direction gives us a square, a 2-dimensional object. Extending a square in a perpendicular direction gives us a cube, a 3-dimensional object. Similarly, extending a cube in a perpendicular direction gives us a tesseract, a 4-dimensional object. Just as a line segment is the 1-dimensional analog of a square, and a square is the 2-dimensional analog of a cube, the tesseract extends this pattern into the 4th dimension. Each step in this progression involves adding a new dimension that is perpendicular to all the previous dimensions. This process can be continued indefinitely, but the tesseract is the first step beyond the 3-dimensional cube. Since we live in a 3-dimensional world, we can't truly visualize a tesseract directly. Our brains are not equipped to perceive 4-dimensional objects, just as a 2-dimensional being would struggle to understand a 3-dimensional object. However, we can use mathematical models and projections to get a sense of what a tesseract looks like and how it behaves. Instead, we use projections, similar to how a 3-dimensional object casts a 2-dimensional shadow. When we project a 3-dimensional object onto a 2-dimensional surface, we lose some information, but we can still recognize the shape. Similarly, when we project a 4-dimensional object like a tesseract into 3-dimensional space, we get a shadow or a projection that gives us some insight into its structure. Imagine a 4-dimensional cube projecting into our 3-dimensional space, much like a 3-dimensional object casting a shadow onto a 2-dimensional surface. The projection of a tesseract into 3-dimensional space can look quite complex, with overlapping and intersecting shapes. These projections help us understand the structure of the tesseract, even if we can't fully visualize it. Here's a helpful way to think about it. Just as a cube can be unfolded into 6 2-dimensional squares, a tesseract can be unfolded into 8 3-dimensional cubes. This process of unfolding, or netting, helps us see how the different parts of the tesseract fit together. Each of the 8 cubes in the tesseract is connected to the others in a specific way, forming a coherent 4-dimensional structure. These 8 cubes interconnect in a way that's hard to visualize fully, but they form the tesseract structure in 4-dimensional space. The connections between the cubes are not along the familiar 3-dimensional axes, but along the 4th dimensional axis. This makes the tesseract a truly unique and fascinating shape, one that challenges our understanding of geometry and space. While we can't physically experience 4 dimensions, the tesseract is used in various fields, from theoretical physics and higher dimensional geometry to science fiction and popular culture. In theoretical physics, the tesseract is used to explore concepts like higher dimensional spacetime and the nature of the universe. In popular culture, the tesseract often appears as a mysterious and powerful object, symbolizing the unknown and the infinite. So next time you encounter a tesseract in a book or a movie, remember? It's a gateway to exploring beyond our three-dimensional reality. The tesseract represents the idea that there is more to the universe than what we can see and perceive. It challenges us to think beyond the limits of our senses and to explore the deeper mysteries of existence. Thanks for watching, and keep exploring the dimensions of knowledge. Stay curious, keep questioning, and never stop exploring the wonders of the universe. Until next time, this is Exploring the Fourth Dimension, signing off. See you in the next episode.